Around the world, tens of millions of people have Alzheimer's disease, a debilitating brain disorder that gradually destroys a person's memory and other cognitive abilities. It takes a heavy toll on both patients and families, as caring for a loved one with Alzheimer's can be emotionally overwhelming and financially difficult. While doctors have studied Alzheimer's for decades, conducting hundreds of clinical trials, there is still no effective preventive treatment or cure. So why is Alzheimer's disease so difficult to treat? Alzheimer's accounts for 60 to 80% of all dementia patients worldwide. Dementia is a broader term used to describe a variety of conditions that affect a patient's memory, thinking skills, and everyday functions. Most Alzheimer's patients first notice symptoms in their 60s, experiencing mild memory problems, like losing track of dates or forgetting what they just learned. Some experience other changes, like frequent shifts in mood, increased anxiety and agitation, and problems with coping in new situations. Symptoms typically progress gradually over years, and eventually a person with Alzheimer's may require constant care. Some rare forms of Alzheimer's are caused by a single inherited gene variant, but most of the time, Alzheimer's is due to the complex interaction of multiple genes in combination with lifestyle and environmental factors. So it's impossible to predict who will develop the disease. Alzheimer's involves a long chronic process, resulting in many changes to the brain that likely starts to unfold at least 1 to 2 decades before symptoms first appear. So it's been difficult for scientists to pinpoint exactly what triggers this process and what causes the many symptoms of Alzheimer's. But thanks to continued research, they're beginning to put this puzzle together. Initially, scientists noticed that the brains of Alzheimer's patients display an abnormal buildup of a compound called beta amyloid. Beta amyloid is created when a large protein, amyloid beta precursor protein, or APP, is broken down. APP plays an essential role in the brain, aiding in neural growth and repair. However, in Alzheimer's patients, it's thought that APP is improperly cleaved, creating sticky beta amyloid byproducts, which easily clump together. These plaques can build up in the spaces between neurons and interfere with normal brain signaling. But this likely isn't the full story. While all patients with Alzheimer's have plaques, not all people with plaques have or will develop dementia. And Alzheimer's symptoms don't always become more severe as plaques accumulate in the brain. In the 1980s, another protein, tau, emerged as a possible contributor. Tau's normal role is as a scaffolding protein to help reinforce the internal structure of neurons and give them their shape. But in Alzheimer's patients, tau is modified and misfolded, causing it, like beta amyloid, to become sticky and to clump. These tau tangles accumulate within neurons and are toxic, causing the cells to eventually die. In patients, plaques normally appear before tangles, yet questions still remain. Do amyloid plaques trigger tau dysfunction? And why exactly do these abnormal proteins lead to such specific disease symptoms? To make matters more complex, recent studies have found that Alzheimer's is closely linked to changes in the way immune cells, called microglia, function in the brain. Others have found that Alzheimer's may also be caused by problems in the junctions between neurons, called synapses, and alterations in the way the brain produces and burns energy may also be an underlying factor. Together, all this suggests that Alzheimer's is likely caused by a complex cascade of events, and teasing out the order of events and how to stop it once it starts will take more research. But there are things patients can do to better manage symptoms. Staying active, learning new skills, and even participating in daily activities like household chores seems to slow disease progression. Medications that target neurotransmitters, the brain's signaling molecules, can slow memory loss and help with learning and reasoning. And scientists continue to develop new therapies, For example, drugs that target beta amyloid have shown promise in slowing the disease and reducing plaque accumulation in the brain. Alzheimer's disease won't go away anytime soon. Dementia cases are expected to double in the next 20 years. But continued research holds the promise of better treatment, and perhaps one day, prevention, as scientists piece the Alzheimer's puzzle together. What if your brain could regenerate itself, updating its own damaged cells? This might sound like science fiction, but it's actually something scientists are seriously looking into.